Good evening, everyone. Am I audible?
Yes, ma'am.
Okay, thank you.
Yes, ma'am.
Let me share my screen. So today's agenda is we will cover week 9 PPAs. So the theory part was discussed in last Saturday session. So first of all, let me give a brief explanation for recursion. So what is a recursive function? Recursive function is a function which can call itself. So basically, a recursive function will have two different parts. One is recursive step, the other one is termination step. So recursive step is the one which we repeat, where we call the function again, and the termination step is the step where we stop a particular using some particular condition. So that is needed in order to stop the function to call itself. So in recursion, what exactly we are focusing? We are actually dividing a bigger problem into smaller problems, or we can say that we are applying the function to the smaller input, and then again the smaller input. Okay, so the first question, just for a brush up, write a recursive function to find the sum of numbers in a list. So we have to write a function, and that should be a recursive function to find the sum of numbers in a list. Okay, so how to define a function? Def sum of numbers, sum recursive, and what it will take? It will take a list. Okay, and what it has to do is, suppose we have a list. Suppose we have a list. L is equal to 1, 2, 3, 4. Okay, and here what we are going to do is we are going to compute the sum of this particular list. What we want is 1 plus 2 plus 3 plus 4. And how to do it recursively? So we will take the first element of the list. We'll take the first element, which is 1, and we will add that 1 to the rest of the list. L of 2, 3, 4. Okay, so I'm not putting L here. So rest of the list after taking 1 is 2, 3, 4. So we'll take the 1, then add with the rest of the numbers in the list. So here what we can do is, okay, let's keep it at that way. And next, sorry, I using shift. Okay, so here we got 1 plus, we'll take the next first element in the remaining list, and then we'll add that 2, and then again it's like we are going to add 1 plus 2, and then we'll add this to rest of the list. Rest of the list is 3 and 4. Okay, and then again 1 plus 2 plus, we'll take 3 and we'll add to the rest of the list. So here finally what we will get is 1 plus 2 plus 3 plus 4, and the sum, as 1 plus 2 is 3, 3, 3, 6, 10. So here you can see we are calling, we have not yet called, but the what we can say, the focus is here. So 1 plus doing something on the rest of the list, and then again on the rest of the list, then again on the rest of the list, which means we are breaking down a bigger list into smaller list, and we are calculating the sum. So what we can do is we can define a function that we can call on this list, right? So that is what we are going to define, recursive function. So what we will do is we'll take that one, then call that sum function over the rest of the list. Okay, so our function name is sum of recursive. Again, we'll call the sum of recursive function on the rest of the list, and again, we'll call the sum of recursive on the rest of the list. Finally, we will get the sum which we want. So, this is a recursive function, the theory part, and and here you can find that this has one part is we are calling recursively again and again. Again and again, we are calling the same function. That is a recursive step. And finally, we have to stop. So, when will we stop? After we take 4, nothing is there in the list. So, we can either we can keep the termination step or the base step to stop the recursive call as check whether list is empty. If list is empty, then you don't have to call the function, rather return whatever the value you have. You understood? Hello?
Yes, ma'am.
Okay. So now let's define this function. So what we are doing is let's write down, yeah, we can add the recursive step first. What is the recursive step? We have to, yeah, and one more thing to remember is we'll use return statement a lot here. Why is that? Because whenever we call the function again and again, so usually when a function is called, stack will be created for that function and all the variables will be put into that particular stack, a part of memory, and then the evaluation will be done. Okay, and in recursive function, as there is multiple calls to the same function, you can assume that there is multiple stacks. Okay, multiple stacks are getting created. Technically it might be different, some activation records are there, but now you consider multiple stacks are created for each of the function. So here for each of the recursive call to the function, now there should be a connection between these stacks, right? So in order to return the value from one stack to the another stack, we have to return the value. So we need the return statement. Okay. Now, so how to add? How can we? Okay. I think we can keep the base step first itself. What should be the base step?
We
Any
can
idea?
write if L is not empty, like if L
Okay.
is not an empty list.
Okay. How can we check whether a list is empty or not?
If len of L is greater than 0,
Um, okay. We want to check whether it is empty. So is it greater than 0?
If length of L is equal to 0, then it is empty.
Yeah.
It is empty.
So if
Then we
len
need
of,
to return list mem.
yeah, if length of L is 0, then we have to return what?
L.
No. So we are adding, right?
Okay.
So what can be added to the rest of the numbers? So that won't change the sum.
Yes.
Can add some number, but it shouldn't change the sum.
Yes.
Yes, ma'am. So before if we can take a variable sum equal to 0.
No, 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 no. Here we are following a recursion, right? So we don't take
Yes,
any
ma'am.
value
Yeah,
as
yeah,
a
yeah.
variable. So we can add 0 here so that it won't make any change, right?
Yes,
So when
ma'am.
the length become 0, which means when the list become empty, we can return 0. So that
Yes,
can
ma'am.
be added to whatever we have already. Clear?
Yes, ma'am.
Yeah. Now, what else?
We can go for else part now.
Yes.
Ma'am, we have to
Is
take
it?
another null no? When length is equal to 1.
Should we take? Can we call it using our recursive function itself?
Yes, ma'am.
Yeah. So the only base condition needed is this length of L when it becomes 0.
Yes.
Yeah. Otherwise, if you take length of L is 1, then you have to return what? Then you have to return the first that element
That
and add
element.
that. Yeah.
Yes, ma'am.
That we can do. One possibility. Sorry. Okay. Then what about the recursive step? We have to return.
List of L0
Yes. Take the
Some
first element and add it to
plus some rec L1
some
column
subrecursive of L. L of
of L1 column.
one column.
one column,
Empty
which
element.
means 1 to last. Take the first element. So the recursive step you can find as the first step that we have here. What we do here, take the first element, then call the function again in the rest of the list. Same thing, right? Take the first element, add it, and call the recursive function for the rest of the elements in the list.
Yes, ma'am.
Okay. So yeah. Now let's call this function print. Let's call sorry call the function with some list 1 2 3 4. Okay, yeah, it's working. So that's
Yes,
it.
ma'am.
You understood the approach?
Yes, ma'am.
Okay. So then we will go to the PPAs. The first question is write a recursive function named triangular that accepts a positive integer n as argument and returns the sum of first n positive integers. Okay, so you have to take a positive integer n and you have to return the first n positive integers. If you see the test case, if it is 5, then you are getting 15, which means 1 plus 2 plus 3 plus 4 plus 5. Okay, so that's what we want. If it is 10, it's 55. 1 plus 2 plus till 10. Similar to what we did earlier. So you have to write a recursive function for this case. Now, okay. So here, suppose n is equal to 5. What we are going to do is 5 plus 4 plus 3 plus 2 plus 1. Okay. Now, by recursively, you can say it as 5 plus if we have some function that can compute the rest, which here we have triangular as a function name. So call the triangular function on what? 5 minus 1, right? So we can take 5 as n. So n plus triangular of, this is our function name that can compute the sum on n minus 1. Get, getting what we did here?
Yes, ma'am.
So this is the recursive step. Okay. So what should be the base step? If it is recursive, this is the recursive step which will repeat, and when we have to stop this, when we have to stop this? When the n value becomes what?
0.
Yeah, when n equal to 0, we have to stop it. So what should return to previous stacks? What value we can return to rest of the values so that our output doesn't change?
0. If n
Yeah,
equal to 1,
if n equal to 0, then you can return 0. Okay, if n equal to 1, then you can return what?
1.
Yeah. So shall we complete?
Yes, ma'am.
Okay. So if n equal to 1, then okay, let me keep it as 0 only. If n is 0, then return 0. Otherwise, return tell me.
n plus
Triangular n
triangular n
minus
minus
1.
N minus 1. Okay, let's run this. Yeah, let's try to run this in Python tutor as well, just to see how that connection is happening. Okay, Python tutor. It's taking a lot of time. I think some network issue. Yeah. So here we go, and I'll call the triangular function triangular on 5. So we call the function, let's say object in Python, and n is 5. Then it's calling n minus 1, which is n of 4. Then again another stack you can consider triangular for n3, and then again for 2, and then again for 1, and for 0 it's going to 10th line this condition, and it is returning 0. This particular stack, this particular function call is returning a 0, and this is given to next. See how it goes. Return value is 0, and then it goes here. That connection will go here, and now what it get? 1, because 0 plus 1, then 3, then again 6, 6 plus 4, 10, then 15. The final return value is 15. Okay, that's it. Now we'll go to PPA2. So here, factorial of a positive integer n is defined as follows. N factorial is equal to 1 into 2 into 3 into up to n. You have to write a recursive function named factorial that accepts a positive integer n as argument and returns the factorial of n. You do not have to accept input from the user, okay? You just have to write the function definition. So here again, hope you know what is factorial. Well, yeah. So if we have to compute 5 factorial, then how will we compute? 5 into 4 into 3 into 2 into 1. Right? This is 5
Yes, ma'am.
factorial. Okay. Now, recursively, how can we do this? Is it same as, okay, what about 4 factorial? 4 factorial is 4 into 3 into 2 into 1, right?
Yes, ma'am. Yes, ma'am.
So, yeah. Now combine this with this. 5 into 4 into 3 into 2 into 1 is 5 factorial. Then we can write 5 into 4 factorial, right? And this again can be written as 5 into 4 into 3 factorial.
3 factor.
Yes. And also we can again break down as 5 into 4 into 3 into 2 factorial, or 5 into 4 into 3 into 2 into 1 factorial. Okay. So, where is our recursive step? This is our recursive step. Okay. If we have some function that can compute the factorial, what we can do is, if you want to calculate factorial of n, then you just have to multiply n with n into factorial of
N minus.
n minus 1. Okay, this you have to repeat. And when we can stop this, what is 1 factorial? 1.
1.
0 factorial is also 1. So the stopping condition can be either this or this. 1 factorial we can take, right? So when n is equal to 1, what we can return? Here, even if we multiply by 1, okay, this won't be there, then it will be direct with the into 1. Okay, that's fine. Yeah. So our base condition is, if n becomes 1, then you have to return 1. Okay. And what is the recursive step? Return. Tell me.
N into factorial of n minus.
Yeah. N into factorial of n minus 1. Is that clear for everyone?
Yes, ma'am.
How many are there? 23.
Yes, ma'am.
Oh,
Yes, ma'am.
okay. Do you want me to visualize this in Python tutor?
No, ma'am.
Oh. So then let's move to PPA 3. Here, write a recursive function named multiply that accepts two positive integers a and b as argument and returns their product. We can only use plus and minus operators. We are not allowed to use the star symbol anywhere in your code. Okay. So we are going to write a function that will actually multiply two numbers, but we cannot use the normal star symbol. We just have to use plus and minus operators if you want. So that's how we have to define this recursive function. Now, so what we have to do, we have to define this multiply a and b. Suppose we have 3 and 5. If we want to compute 3 into 5, which is 15, what exactly we are doing? We are adding 3 how many
5 times.
times?
5 times.
Yeah, 5 times. So it's repeated addition. Multiplication is repeated addition. So otherwise we can also say it is 5 plus 5 plus 5. Right? We can say either A is added to itself some B times and vice versa. Both are correct. Now we have to convert this into a recursive form. Okay. I'll take this 3 plus 3 plus 3 plus 3. So this is 3 into 5. This is our A and this is our B. Okay. Now 3 plus what we did. What we did? If we have a function that can compute sum of
A comma,
these
we can
numbers,
write 3 comma 5 minus 1.
yeah, it's 3 comma 5 minus 1, or you can generalize it as A plus B,
Comma A minus 1.
sorry, A minus 1. Okay, so we have to write a function for this. So that is our recursive step. What will be our base step, termination step?
We can write A plus multiply A comma B minus 1.
Yeah, right. Yeah. So recursive step is multiply, oh, sorry, A plus multiply A comma B minus 1. Okay. How will we stop this? This is the recursive step. What should be the termination step? When the number is 0, you can just return the 0 so that it won't make any change in our sum. Okay.
Yes, ma'am.
Yeah. So it will be based on our B. When B becomes 0, then we will just return a 0. Okay. Let's convert this into code. I'll write the recursive step first. Return. So here we are taking A and B. Okay. Return A plus
Multiply
multiply.
A
A
comma
comma B
B
minus
minus
1.
Yeah. And if B
B is equal to 0.
0, then
Return
Return
0.
0.
return 0. Okay. Is that fine for everyone?
Yes, ma'am.
Oh. Now we'll move on to PPA 4. Here. Sorry. Consider a positive integer x that is a power of 2. The logarithm of x to the base 2 is the number of times 2 has to be multiplied with itself. So get x, and is denoted by log base 2x. For example, log base 2 of 4 equal to 2. And also note that log base 2 of 1 is equal to 0. You have to write a recursive function named logarithm that accepts this positive integer x, suppose 4, as argument and returns log base 2 of that particular x. You should get 2. Let me explain here. Are you familiar with logarithm?
Yes, ma'am.
Okay.
Yes.
So here we are considering only log of 2, okay? Log base 2 of x. So see here, 2 raised to 0. 2 raised to 0 is 1. 2 raised to 2 is, sorry, 1, I missed 1. 2 raised to 1 is 2. 2 raised to 2 is
4.
4. 2 raised to 3 is 8.
8.
2 raised to 4 is
16.
16.
16.
2 raised to 5 is
32.
32.
32. Yeah. Now, how we will represent using log C? Log base 2. So base is, this is a base, okay? Now, and log base 2 of 1. This is the 1 I put here. Log base 2 of 1 is
0.
0.
0. So the power. Now, log base 2 of 2 is
1.
1. This one. Mm, okay. And log base 2 of 4 is
2.
2. Log base 2 of 8 is
3.
3.
3. Log base 2 of 16 is
4.
4.
4. Log base 2 of 32 is
5.
5.
5.
So, logarithm means to what power a number. Here in this case, for example, 1, if we take this one, to what power this is raised to get this number? That is the question. That's how we find the log. Okay. So 2 raised to 3 is 8. So log of 8 is 3. Now, yeah. And let's see the relation between these numbers and these numbers so that we can uh, get our recursive function. So here it's like we are increasing 2. I mean, we can divide this by 2 and get 16. And here again divide by 2 and get 8. 8 divided by 2 will get 4 and so on. Okay, by division we are getting the next number. Okay, so in recursive functions we always start from bigger to smaller, right? Whenever we calculated factorial, we said n into factorial of n minus 1. So let's start from the lower part, the below here. So what we are doing, dividing by 2. So that will come as a step in our recursive step. Okay, so
Yes, ma'am.
yeah, and here again, this is our calculated number, right? So what is the relation? It is increasing by 1, right? 0 plus 1 is 1, 1 plus 1 is 2, likewise. So it here it is plus 1. Okay, from all this information, I'll be able to write the code for logarithm, calculating logarithm using recursion. So let's see. First, I'll write the base step. So when, what is the base step? Base step we can, which number can be taken as the base step?
The first one.
Yeah.
1 base 2.
So log of 1 can be taken as base step, which means here we are taking x as x, right? The variable. So if x is equal to 1, then what
Return
we
0.
have to return?
Return 0.
Yeah, right. And in all other cases that we can formulate from 2 raised to 5 here. So, yeah. Yeah. What we add every time? Every time the number that we add is
1.
1. 1 plus, call the function log of, what we have to call?
Divide by 2.
X divided by 2.
Log of x divided by 2, because 32 by 2 we get 16, so we can do that.
Ma'am, will it be integer division or float division?
Yes, this will be an integer division.
Ma'am, actually, the other division also works. I've tried.
Oh, is it? Okay. So here we code x equal to 1, then return 0, otherwise return 1 plus log of x divided by 2. Is that clear, everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay. Yeah. Then we'll move to the next PPA. Here, write a recursive function named Palindrome that accepts a string word as argument and returns true if it is a palindrome and false otherwise. Okay, what we have to do? We have to write a function palindrome that will accept a string word as argument. Okay, if it is palindrome, it will return true. If it is not, it will return false. That's it. But that should be a recursive function. That's all. Okay, what is a palindrome? A word is called as palindrome when its reverse is equal to the same word. When word is equal to reverse of word, it is called as palindrome. Simple, right? An example is Malayalam. Okay. Now you see the first and last letter is same, A and A again same, L L A A and Y. So if we reverse it, we'll get the same word. So this is called as palindrome. Now what we have to do is we have to find that word is palindrome or not using recursion, recursive function. So what do you think? The first thing that we will check is the first and last letter of this particular word, right? Okay, first thing is we'll check the first and suppose this is a string, then we'll check whether s of 0 is equal to s of minus 1. Okay, first thing that we will check is first and last letter. And if it is same, then what you have to do? You have to check on the first, I mean the index position 1, the second letter to the second last letter. Again, same, you have to repeat third to third last letter, fourth to fourth last letter. And maybe there will be one extra letter in between and at the center. Okay, otherwise there won't be anything. That can be considered as our base condition. If suppose s of how can we check whether something is there? Length of s is 0, or what we can do, less than or equal to 1. Either it is present or not. Either it is odd length or even length. The word is odd length or even length. Okay. If length of s is less than or equal to 1, then return, which means we have reached the center, right? When will we reach the center? Only all when all other letters, the first and last, second and second last are all equal. Then what we have to return?
True.
Yes. Then we have to return true. That is our base condition, termination condition. What about the recursive step? What we can do is check whether the same thing. First letter is equal to
Last letter.
last letter. Yeah. If so, then call what? The
Return
function that we are in.
palindrome.
Yeah.
1 colon minus 1.
Yes. 1 to minus 1. Okay. We want to leave this. That's why we have to include this as minus 1. Okay. And this is for true condition, right? Both. In all other cases, you just return
False.
false. Let me finish the coding. So here, palindrome of word. Okay, so if len of word is or less than or equal to 1, then no need of bracket. This is just okay. So if length of word is less than or equal to 1, then return true. We have reached the sender. And another condition is if word of 0, we have to check first letter is equal to last or not. Then if it is equal, then call the function on rest of the input, which means second to last. I mean repeat. So it should be word of 1 to
1 to minus.
minus 1. In other cases, return false. Is that clear?
Ma'am, here 1 to 1 is not clear.
Okay. So see here. For the same case, Malayalam. First thing is we'll check as word of 0 m is equal to word of minus 1. Okay. First and
Yes,
last
yes.
done. If it is true, then we enter into the if block and call, and we have to call the function only for this to this, right?
Okay, okay, got it, got it.
So the minus 1 will skip that last letter.
Okay.
Okay. Shall I move to next problem?
Yes, ma'am.
Okay. So here it's PPA 6. Consider a spiral of semicircles. Just focus on this question, okay? It's simple only, but yeah, just listen carefully. So consider a spiral of semicircles. We start at a point P0 on the x-axis. So this is x-axis, and here we have y-axis, and the coordinates is L0. Here this is L0 because it is lying in the x-axis, so y coordinate is 0 and x coordinate is L. And the second, okay, the first arm, so what is arm here? P0 to P1. Okay, this particular arc you see here, this is called as arm. P0 to P1. P1 to P2 is another arm. P2 to P3 is another arm. And see it properly. I'll go back to so see here P0 to P1 is one arm, P1 to P2 is another arm, P2 to P3 is another arm, and P3 to P4 is another arm. Total how many arms are here? 4.
4.
Now, yeah. And the coordinate you can see P0's coordinate is L, 0 coordinate because all are lying in the x-axis. Now, the first arm of the spiral ends at P1 with coordinate R0 and start at L0. So this is the starting point. So for P0 P1 arm, P0 is the starting point and P1 is the ending point. And for P1 P2 arm, P1 is the starting point and P2 is the ending point. What about P2 P3, which is the starting point?
P2.
Yeah, P2 is the starting point, P3 is the end point. And now again, we have only P0 and P1, right? How can we find the coordinate of P2? You see, P2 lies at the center of P0, P1, right? This is
Yes,
the center. So how can we find the coordinate, the x coordinate? X coordinate will be,
L minus R by 2.
yeah, L plus R by 2.
Oh, sorry, yeah.
Yeah. Either R minus L by 2 or L plus R by 2. We'll take L plus R by 2. And then again, for P3, we can find the coordinate using x coordinate of P2 and P1, right? R plus, if something is there for P2, let's consider L, no, no, L, R, S, okay? R plus S by 2 again. Again, we will get it by dividing, sorry, just add and divide by 2. So we can say that it is a recursive thing happening here, right?
Yes.
Yeah. And also one more thing to notice is this is the start point, this is the end point, and for the next arm P1, P2, the start point is end point of the first arm P0, P1. Getting it?
Yes, ma'am.
Okay. So keep all the points, I mean, all the things that we discussed till now in the mind. Start point, end point, finding the midpoint. These many things are enough. Now let's see what we have to do. Write two functions named spiral iterative and spiral recursive, each of which accepts three arguments. So we have to do this in two different ways: iterative way, the normal approach, and the recursive way. And the arguments these functions accept is left x coordinate of the point P0, right x coordinate of the point P1, n is the number of arms in the spiral, and both functions should return x coordinate of Pn. Pn means the last one, right? The point at which nth arm of the spiral ends. Okay.
Yes,
So
ma'am.
here in this case, this point we have to return. Is the question clear?
Yes, ma'am.
Okay. So let's do this. Yeah. So first approach is an iterative function to compute the x coordinate of the nth arm of the spiral. So right. Okay. Let's keep this as start and end. Start, end. Finally, we have to return the end value, right?
Yes, ma'am.
Yeah. Okay. So how can we do this? For iterative approach, so we know the number of times that we have to repeat. So for loop we can use for I in range n or n minus 1. It's n minus 1. If you see the number of arms, so 0 to, if we have 0 to n, it's actually n minus 1, right?
Yes,
So,
ma'am.
yeah. So all the time, what we are doing is the start point will be replaced with the end point of the previous arm, right? So just initialize start with end, and what will be the new end value? Which means you just think about the second arm. That will be easy. So P0, P1 is the first arm. For P1, P2, we are doing this. For P1, P2, if we are finding the start and end value, what will be? What will be the value? So start will be changed to end, and end will be start plus end by 2. Okay. And finally, what we have to return? Return end. Okay, let's check whether it is working. The iterative approach. Hmm, I think something wrong. We got 1.00, expected was 0.667. Article end.
Ma'am, for I in range of n minus 1, for
Yeah,
is in for loop, I is I will take value from 0 to already n minus 1. We don't have to subtract minus 1, I think so.
let's try that then. No, no, no. Looks like something else.
And the start and end value have the same value, no?
Start and end will be the same value. How?
We are initializing start to end, then again using start and end. So it's end plus end by 2.
Hmm, right.
It should be start plus start.
No, no, no. No.
Ma'am,
Yeah, yeah.
it's saying spiral recursive is not defined. The error. So if there is a ellipsis, then no need to comment.
No need to comment this.
There is ellipsis, or we can add ellipsis in the function body. Error it is showing spiral recursive is not.
Yeah, but
Can
we don't have ellipses. Okay.
we can
We'll
add
add.
ellipsis.
Mm, mm, 1 second. Let it start in, and we are trying to wait. Okay, here it's getting. We are losing the value, right? We'll do it in a single line. This will work so that we don't update the value. We don't use the updated value. Start place end by. Yeah, that was the problem. Yeah, one who told now that is the actual issue, but you can solve in this manner. Yeah, you got it? Why we got wrong?
You can explain it once again.
Yeah. So when we do it in a separate line, what happens is the start value gets start equal to end, right? So start value gets updated with the end value. So both values will be same. But here it's just we are in swapping we do this, right? So we can swap in a single line in Python. So where the value won't get disturbed. So it's like the value won't be updated. You got the difference? So when we do in this manner, start equal to end and end equal to, okay, I'll show this in tutor. So when we call this, so here you see when we reach the for loop. So here start is 0, end is 6, n is 2 and I equal to 0. Now see start and end both are 6, right? So we don't want this to happen. So for that what you can do is just do it in the same line. Now start is 0, end 6, end 2, I 0. Now start is 6, end is 3.0. Understood? This is for the first one. Finally, we'll get the end as 3. The updated end value we don't have to take. We should not take. Clear? Is that clear or do I need to explain again?
Understood, ma'am.
Oh. So that's about iterative
Can you explain it
style.
once again?
Okay. So see here. You want me to do here? Okay. I'll try this way. So here see. So when we assign start equal to end and then end equal to start plus n by 2, this start, the value for this start is actually the updated value for start, which is actually the end value. Okay.
Okay, ma'am.
Yeah. So but what we want is the original start value. For that we have to do it in a single line tuple. Okay. Now the recursive style, how we can do the same thing. So in recursion, yeah. So we have our n arms, and when n reaches what 1, then we have to call the last arm. Otherwise, what we have to do, we have to call whatever the function that we define, recursive function. Call the recursive function with, tell me the values, start value, end value, and the n value. So n value will be what? N minus 1. What will be the start value? Start value will be for the recursive call. What do you
Right.
think? Yeah, left, right. In this case, start and end. So
Right.
it will be end, right? I'm using start and end variable. So
Okay, end. Sorry.
yeah. So and for the second argument,
Start plus end by 2.
right, it will be start plus end by 2. Okay. Everyone understood how we did recursion, recursive way? Any doubt?
Can you repeat it once again, the end part?
Yeah, this part. So here we want to call the recursive function, the spiral recursive function, on which input that we have to take care of. So earlier when you, if you remember the other cases, we always go for the second part, right? The second step. So in this case, you just consider this particular step. So here what we did is start is next, for the next call, the start is end, and for end will be replaced with start plus end by 2. So that will be our second argument. And for how many number of arms we have to call again? N minus 1. Clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So let's convert here. If n is equal to 1, then return the end value. Otherwise, call spiral recursive and values for start, end, and end. That will be end will be replaced, sorry, start will be replaced with end, and for end it will be start plus end by 2, and then n minus 1. I think it's keep this in bracket. Okay. Okay, done. Is that
Ma'am,
clear?
ma'am,
Yeah.
I did the same code. In public test, it is 2 out of 2, but in private test, it is 4 out of 5.
Mm. Okay. Let me check. No, it's 5 only.
Okay, ma'am, let me check because I did the same
You
thing.
check whether you have the. Mm,
Return and comma start plus n by 2 n minus 1. Yes, ma'am, I did the same thing.
what about the iterative function?
Uh, yeah, ma'am, same.
Okay.
Okay,
Try
okay.
again.
I got it. I
Try
got it. I got
submitting.
it. I got it. I wrote n
Okay.
minus 1. N
Okay.
instead of n minus 1.
Okay. Okay. Got it. So
Thank you, ma'am.
yeah, if that is fine, I'll move to next one.
Yes,
Okay. Here, write a recursive function named count that accepts the following arguments: L, a list of words, and then word, a word could be any string. This function should return the number of occurrences of word in L. You cannot use the built-in count method for list in this problem. All words will be in lowercase. Okay, so let's try. Okay, so suppose we have a list L. L is equal to L is equal to 1, 2, 3, let's have one more one. Okay, enough. Now let me give the word as 1 to find the count of 1 in this particular list. That is the aim. Okay, and what should it return? The count value should be 2. Okay, and let's see how we can do this. So yeah, how we have to do this in a recursive way? Take the first element, and then what we have to do? Suppose if the first element is, if L of 0 is the word that we pass. If it is the same word, then we will count that, right?
1
Yes, ma'am.
plus
Yeah, we'll count. So 1 plus,
the method with remaining elements.
yes. So 1 plus, call the method. So suppose we have method as count only. Count of L of 1 to,
1 colon
yeah, 1 to last. And okay, we have to pass the word again, right? Because our,
word.
yeah. And what about if L of 0 is not equal to our word? Then shall we stop right there?
Oh no, ma'am. We have to complete the entire array.
Yeah. So we can call the function without adding this one.
Without adding 1.
Yeah. Just call the function again with the rest of the list. Okay. What about the base condition? How can we stop? It's a list. So how can we stop?
Ma'am, if the length of the list is 0, then return 0.
Right. So that is the stopping condition. When the length of list becomes 0, just return 0. Count of L comma word. If len of L is 0, then return 0. Okay. If L of 0 is L of 0 is,
Equal to what?
yeah, equal to word, then add that 1 plus count of L of 1 to last, and then the word.
And capital L.
Yeah. Otherwise return,
The count.
yeah, just call the function. Okay. Then is that clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll move to next one. This is PPA 7. Okay. Now here write a recursive function named non-decreasing that accepts a non-empty list L of integers as argument and returns true if the elements are sorted in non-decreasing order from left to right and false otherwise. Okay, so what we have to do is we have to take a list of integers, and if the elements are sorted in increasing order, which means non-decreasing order from left to right, then return true, otherwise return false. If you see the test case, here we have 1, 10, 100, 1000. here it is in increasing order, right? 1, 10, it is less than 100, again less than 1000. So it is true. Here it is 10, 100, 1000, 10,000. As 10 is not less than 1, output is false. Okay. So let's see. Yeah, here repetition. 1, 1, 2, 3, 3, 5. This is also fine. 1 is less than or equal to 1. So 1 is less than 2, 2 less than 3, 3 less than or equal to 3, 3 less than 5, 2. So we got true here. Is the problem statement clear?
Yes, ma'am.
Okay. So how can we do this? So here, if we have a list 1, 2, 3, 4, how we are finding? We are taking the first element, checking whether it is less than or equal to second element, right? L of 0 is less than or equal to L of 1. If this satisfies, if it is equal to true, then what we will do? We'll try with the rest of the elements. Correct?
Yes, ma'am.
Okay. So one condition is the same condition. If L of 0, if L of 0 is less than or equal to L of 1, then call the function, if we, the function name is non-decreasing, call the function non-decreasing on what?
L of 1
L of
to
1 column, 1 to last. Okay, that is in the case of when first element is less than or equal to second. And what will be, yeah, this will go. Okay, if it is not, then we will return false. Okay, so recursive step is done. What will be the base step?
If the length of the list is 1, then return true.
Okay, if length of list is 1, return true. Okay, let's try this. If len of L if length of, sorry, if length of list is 1, return true. If L of 0 is equal to L of 1, then
Less than equal to, no?
wait,
Less than
ah,
equal to.
L of 0 is less than equal
yes,
to.
yes, yeah, forgot. So if it is less than or equal to L of 1, then return then call the function on the rest of the list, on to
Ma'am,
last.
instead of underscore, you have written hyphen.
Yeah, thank you. Now this is for false. Is that clear? The logic?
Yes, ma'am.
Okay. And shall I move to next one?
Yes, ma'am.
Yeah. So here, write a recursive function named unique that accepts a non-empty list L as argument and returns a new list after removing all duplicates from it. Your function must retain the last occurrence of each distinct element in the list. Okay, this is like you have to remove the duplicate elements from the list. Okay. And also it is said that you have to return the last occurrence of each distinct element in the list. So if we have a list like 1, 2, 3, 4, 5, and let me keep 1, 2, okay, enough. This is too much. I think it will take a lot of time to explain. Okay, 1, 2, 3. Again, let's repeat 1, 4, 2, 3. Okay. So here, what should be our output? The output should be, this is the input list. Output list, the new list will be, so we will check first 1. 1 is present in the rest of the list. Yes, it is present. So discard this 1. 2. 2 is present in the rest of list or not? Yes, it is present. Discard this 2. Next 3. 3 is present in the rest of the list? Yes. Then discard this 3. Then again 1. 1 is present in the rest of the list? No. Then take that into our new list. 4. 4 is not present anywhere else. Next 2. Next 3. So this will be the output list, the new list. Okay. Now, so if we have a recursive function, unique. Okay. Now, what we have to add the element? Usually we add some numbers, right? 1 plus something. So here what we have to add for the recursive call? If the element is,
List of L0.
yeah, consider list of L0, but all the time it is not list of L0, right? We'll find a unique element and we'll add that. In this case, the 1. So we'll add the 1. How? Before that, we'll check whether 1 is present in the list. 1 is present in the list or not. In list or not. 1 in list, if it is false, then we'll, sorry, 1 in not the list, the rest of the list, then we will add that 1 and call the unique function in the rest of the list. L of 1 to last. And again we will repeat this 4. In the second case it will be 1 plus 4. 4 is the next element, right? And then unique of the rest of the list will be 2, 3, right? And this will be appending all the time. 1 plus 4 plus 2 plus 3. We are adding elements to the list. And what can we add at the end? An empty list will be fine. So for the base case, usually we add 0 for numbers, right? So in that sense, we can add an empty list to the list so that we won't get any type error. Getting it?
You can explain it once again.
Okay. So here we have 1, 2, 3, 1, 4, 2, 3. And output we get is 1, 4, 2, 3. Okay. First thing is we will check whether 1 is present in the list or not. 1 is present in this part of the list or not. Okay. So let's take it as L of 0. We'll check whether our first element is present in the list. From where to where we have to check? 1 to last. Whether L of 0 is present in the rest of the list. If it is present, then we don't want to add this particular element to the new list. Okay, we don't want to add. So we will just call the function unique function in the rest of the list. How will we call? Unique of what? What should be the input here? L of
1 to
from
last.
second, 1 to last. Okay,
Yes.
and yeah, what about the other case where the element is not present in the rest of the list? If it is not present, then we want that element in our list, right? Okay,
Yes, ma'am.
yeah. So let's keep it here. We have a list. I'll take an empty list, so we don't name it as it is a recursive call. We'll just return the list. So we'll add which element, that L of 0, to this particular list. Then call the unique function in the rest of the list. This is the else condition. First thing is we'll check whether the element is present. If one is present, then we'll just call the unique function in the rest of the list. If the element is not present, suppose we reach the second one here. Suppose we reach this part 1, 4, 2, 3. In that case, we see that one is not present in L of 1 to last. So we'll add that 1 to this particular list, L of 0. This L of 0 will be added to the new list that we are going to return, and then call the unique function in the rest of the list. Clear?
Yes, ma'am.
Okay. And when we have to stop this, normally this is a list.
When the list is empty.
Yeah, and the list is empty, we can return the list L back. So if length of list is uh, yeah, if the list is empty, then we can't return the list, right? Let's keep the last element inside the list. So when it is and the length is 1, then return the list. Sorry. If L of 0 is present in 1 to last, then you have to call the function again, unique function again from 1 to last. If it is not present, if it is a unique element, then add that element to our list L of 0. Make of L of 1 to last. Okay, you understood? If it is an a
Yes.
one, if it is a list with a single element, that is already a unique list, so you just return it back. Otherwise, we'll create a new list using the condition. Okay. Now, yeah. Have you gone through the lecture for binary search?
Yes, ma'am.
Okay. So here we have to write a recursive function for that search. Sorry. Okay, here we have to write a recursive function named search that accepts the following arguments. L is a sorted list of integers. This is a sorted list, and k is an integer. And what you have to do is the function should return true if k is found in the list L and false otherwise. So we have to write a function that will search an element is present in a list or not. Okay. Now, yeah. Let me see the test case. 1, 2, 3, 4, and here it is 10, 20, 30, 40, 50. So it's a sorted list, right? It's a sorted list. So when we have a sorted list, we can go for binary search algorithm. That will be better. Okay. So you want to know how does it work? Binary search. So the logic of binary search is, suppose we have a list 1, 2, 3, 4, 5, 6. Okay. So binary 2. Now this is our list and element I want to search is 2. Consider the element I want to search is 2. I want to check whether 2 is present in the list or not. Now what I will do is, as the list is sorted, okay, linear approach, I'll tell the linear way of doing this. How will we search normally? I'll just go to the list, check whether the given element 2 is equal to 1. If it is not, we'll go for next, whether 2 is equal to the second element. Otherwise, we'll go for third, then fourth, then fifth, then sixth. We'll go likewise, right? In binary search, what we do is, as this is a sorted list, so first the element is 2, okay. Now, we'll check whether, we'll take the middle element and we'll check whether it is equal to our, the element that we have, and then we will go with the left part. Basically, we'll divide this list into two parts, left side and the right side. We can say as left list and right list. And if the given element is less than the mid element that we calculate, then we'll check the left part of the list. Otherwise, we'll check the right part of the list. Okay, again we'll take the mid element, and again this list will be divided into left and right, and again we'll check by dividing left and right. So it's like we are dividing the list again and again into two parts and then checking. Are you getting it?
Yes, ma'am.
Okay. So let's, yeah. So one thing is we have to find the mid index, right? So that is the main part. So mid index will find, how will we find mid index? We want to get the first and the last index. Okay, first and last index, and then we have to divide by 2. So let's keep left and right of the list as, left will be 0th index and right will be, how can we
Length
get,
of L.
yes, length of L will be the length of the list. So the index position will be -1. Okay. Now mid we can find by dividing left and right by 2. Left plus right by 2. Okay. Now we'll check whether the mid element is equal to our search, whatever that we want to search element. So if L of mid, the mid index is equal to our element is k, then you just have to return 2 because we found the element. Okay, and next we have to check the left part. How we will check? If L of mid is less than our number k, then we change the left and right. So here you see. So after dividing this 1, 2, 3, 4, 5, 6, so yeah, for our case, yeah, L of, yeah, once again, mid is equal to 0 plus 5 divided by 2. Let's keep it as 2. Okay. Now we'll check 2 is 3. 3 is equal to L of mid is less than L of mid less than k. Any mistake I made here? Mid element is less than the k. Yeah, right on. So if mid element is less than k, the left part of the list, then yeah, here in this case, here let's keep this as 4 or 5. It would be 5. So if it is in the right side, which means L of mid, let's take it as 3. 3 is less than our element, search element 5. Then we have to check which part? The right part. Are you getting it? We are going to check the right part. So if we are checking the right part, then what will be the value for left and right? What will be left index and right index? Left index will be mid
Mid
plus
plus
1.
1.
Yeah. And the right index will be the last index.
Minus 1.
Right index will be just length of L minus 1 or just the right itself, right?
Right.
Okay. Yeah. So here left comma right, left is equal to mid plus 1 and right is equal to just right. Okay. And this is for right side checking. What about opposite case? When L of mid is greater than the
Ma'am,
element, which means we
ma'am,
have to check. Yeah.
ma'am, for
Yeah,
the
yeah. Tell
second
me.
condition, we don't need
Mm.
to assign value to red. Yeah, I'm saying,
You are saying,
can we leave it
yeah.
as it is without assigning value for right?
Can we leave it as it is? You are asking that, right?
Yeah, it is as usually last index.
I think let me check whether we can leave it as it is. Okay.
Sorry.
So yeah. No, it's okay. I'll check. So then the other part is left side. If we check left side, left will be remaining as such. I think we can leave it as it is. Otherwise, it's mid minus 1. The right will be mid minus 1. This part, left part. Now, yeah, so we just had the definition. Now, we have to make it a recursive call, right? How can we do this? Call the function again, L of what? Sorry.
1 colon,
We have to
left
call it,
colon,
left colon, right, right plus 1, and then give the
k.
k. Yeah. So give the list and then call it, and we have not added the base case. What will be the base case? Same as it is a list. When it is the list becomes 0, 0, then okay. In all these cases, what we did, these are meant to work for true case, right? So if this doesn't return true, which means when we reach the end of the list and still we couldn't find the integer is present or not, whether integer is present or not, then you return false. Clear?
Yes, ma'am.
Ma'am, can you explain the last line?
Ma'am, can
Last
you
line.
explain
This
this
line.
again, please?
Yeah. I'll let me run this and see whether it's working. Okay. So we are doing binary search. In binary search, we have to first what we'll do is we'll give a sorted list and an element, and we'll check whether the element is present in the sorted list or not. As the list is sorted, the better way to search is using this algorithm called binary search algorithm, where what we will do is we'll divide the list into two halves, left and right halves, okay, and then we'll compare the element that we have and the mid element of the list, and if the mid element is less than the element that we have, or the other way is better, whether the element that we have to search is less than the mid element, then we will search in the left part of the list, and if the element that we have is greater than the mid element means the element at the mid position of the list, okay, then we will search in the right half of the list. So this is like we will divide this list again and again till we find the element is present or not. If we reach at a point where the list is empty, then we say that we have not found the element. So in that case, we will return false. Okay. And other cases are here. The first case is this is the best case of binary search algorithm when the mid element is equal to the element that we search of the list. And this is for checking in the left part of the list. So this is like not, it won't be done in, it can't be done at once, right? So if we just divide list into two halves, and if the left part and right part have more than one elements, then we may have to divide the list again into two halves. The left part will be divided again, and again the search function again in the left part will be assigned to the element here. The first case is when we correct the right index, finding the mid position, then checking whether the element is equal to the mid element or not. If we find it in the, if the element is mid element, then return true. If the element is not the mid element and if it is less than k, check in the right part. Sorry, here I say it as opposite. So if the element is greater than the mid element, check in the right part. And if the element is less than the mid element is less than the mid element, then check which part. You tell. Left part. Okay. And we have to call this function again and again to do this operation. Is that we will divide the list into two halves, again into two halves, again into two halves till we find the element. For that, this is the recursive call for the function. Getting it?
What does left to right plus one mean?
Here.
Yes, ma'am.
Okay. So yeah. So once we do all these things, okay. So we want to pass either one part or the other part. So if we pass this particular list, left part of the list, so we want to pass not just the entire list, but from this position to this position, right? So we have the index value for first and last of this sublist in our left variable and the right variable. That's why we pass left and right plus 1. Got it? Why we added 1?
Okay, ma'am.
If we do not add it, we'll skip one element, right? That's it. Got it?
Yes, ma'am.
Any other doubts? Hope it is clear. Okay, I'm stopping here, PPA 10. Okay.
Okay,
Rest
ma'am.
of the questions will be covered in coming sessions. Okay.
Okay, ma'am.
Okay, ma'am. Thank you, ma'am.
So,
Thank
thank
you,
you
ma'am.
everyone.
Thank you.
Thank you, ma'am.
Thank you.